Hello students. So let us continue in this video with chapter 10 Light of 10th class. In the previous video we have seen the ray diagrams showing image formation by concave mirrors. We know that there are two types of spherical mirrors, concave mirrors and convex mirrors. In this video let us see how image is formed by reflection by convex mirrors. I hope you remember students that before drawing the actual diagram showing image formation, we should know that after drawing the object AB, from A we have to take at least two rays, incident rays, which strike the surface, reflecting surface of the mirror and get the two reflected rays and get the point of intersection where the rays actually meet or appear to meet. And that point is then the image of A, and hence we can draw A dash B dash as an image of AB. But before drawing those diagrams, we have to learn certain rules. Okay, every time we cannot take D and measure I and R to be equal. Let us see which specific rays we can use to draw easy ray diagrams. Now before that we should know how to make this. I have already taught you in the previous class that you have to take a compass, keep the tip of the compass at some point and then open it wide and draw this curved part, okay, a part of circle you draw here. Show the polishing. We know that convex mirrors are the spherical mirrors whose reflecting surface is curved outwards. So we have to polish the inner side, okay, and name this aperture as mm dash. Central geometrical center of the reflecting surface of the mirror is pole, where the tip we have placed of the compass is represented by capital C, it is center of curvature. And for mirrors, spherical mirrors having smaller apertures, it means where the aperture is smaller than the radius of curvature. In such case, we know that F, that is principal focus, lies midway between pole and center of curvature on the principal axis. So first of all, this basic thing should be drawn by you. Now let us see how to draw the specific incident rays and get the reflected rays. Let us consider this first case. One type of ray that we have used before is a ray which is drawn parallel to the principal axis. So I have drawn a ray which is parallel to the principal axis. We know that at this point of incidence, the normal is obtained by joining the center of curvature. You have to use a dotted line to draw the normal here and this point of incidence. So at this point of incidence, this is our incident ray and this is our normal. So this becomes angle of incidence, angle between the incident ray and normal at the point of incidence. We know the law, I is always equal to R. This is one of the laws of reflection. And the reflected ray lies on the other side of the normal. So by using D, but otherwise we have already seen this before, that whenever the ray is parallel to principal axis, after reflection, in case of convex mirror, it appears to be coming from focus. Let us see how. Now here, this is my incident ray, this is normal. After reflection, the ray bounces back like this. It means this is now my reflected ray. So this is the angle between the reflected ray and the normal at the point of incidence, denoted by R, and it is angle of reflection. I have drawn this ray in such manner that I is equal to R. So I have followed the laws of one of the laws of reflection. Now in this case, when reflected ray is produced backwards, we have seen this before also. When it is produced backwards, it meets focus on the principal axis. If you remember the definition of focus, students, we have already defined focus as a point where the rays parallel to the principal axis meet or appear to meet. In case of convex mirror, appear to meet after reflection. So in case of this first ray, when it is parallel to principal axis, after reflection, we have seen that it appears to be coming from focus. Okay, so this becomes one of the rules now. While drawing the actual ray diagram, when we take the object, it is not necessary to draw this normal and show the angles. we can directly draw a parallel ray appears to be coming from the focus. So I hope you have understood this case. Now let us consider the second type of incident ray, which is very simple. We know the law of reversibility of path, that light retraces its path back. Suppose if this is our incident ray, this becomes our reflected ray. We can easily see that if this is I, R should be equal to I, then this will be a reflected ray with arrows in the reversed direction. So in other words, if I take my incident ray directed towards focus, it means if I take my incident ray directed towards focus, this is now my incident ray. So at this point of incidence, I have to draw the normal. Normal is a dotted line passing through the center of curvature and this point of incidence. Okay, now this becomes angle of incidence, and on the other side of the normal will lie our angle reflected ray. Now reflected ray should be such that I is equal to R. So when I follow the law and draw the ray, I see that this is my reflected ray. This is the angle of reflection represented by R, and we can see here that I is equal to R. So following the laws of reflection, I have drawn one incident ray which is directed towards principal focus of a convex mirror. After reflecting from the surface of the convex mirror, it becomes parallel to the principal axis. So again, you can remember always this. Out of the two rays that we have to draw from A point, we can choose either this, or you can choose any one of the next two rays also. Let us see how. Now in the third case, let us consider the case of normal incidence. Normal incidence, you know, when a ray is incident normally, I is 0 degree, and in that case R is also 0 degree. I is 0 degree means angle made by the incident ray with the normal is 0 degree. So first I'll draw the normal, and let me choose this point of incidence, and I'll draw the normal here. I have chosen this point of incidence, which is not far away from the surface principal axis. I have drawn the normal. So if my incident ray is directed towards center of curvature, it means when it is along the normal, I is equal to 0 degree. R should also be 0 degree. It means my reflected ray will be this. It will retrace its path back. So in this case, again the next rule is, whenever incident ray is directed towards the center of curvature, in case of convex mirror, after reflection it reflects back along the same path. Now last ray that we can choose is this oblique case. When a ray is incident obliquely with the principal axis at pole, if this is my incident ray and this is angle of incidence, then again following the laws of reflection, we know at this point this is a normal, because normal is always a line joining C and that point of incidence. This is a point of incidence, so principal axis itself is a normal. So on the other side of the normal will lie our reflected ray. This is my reflected ray and this is angle of reflection. Again we have to follow that I is equal to R. So we are following this law. Okay, following this law, I have drawn these four rays, special rays. Let me repeat it. We can choose any of the two rays. Which rays are these? A ray parallel to principal axis appears to be coming from focus after reflection from a convex mirror. A ray which is directed towards principal focus of a convex mirror becomes parallel to the principal axis after reflection. A ray which is directed towards center of curvature of a convex mirror, after reflection it reflects back along the same path. A ray which is incident obliquely with the principal axis at pole, we can use the laws of reflection, that I is equal to R, one of the laws, and draw the reflected ray on the other side like this. So friends, out of these four rays, you have to select two rays, and no need to draw the normal every time. Now we have formed the rules, and we can easily draw the image formation diagram ray diagram by convex mirrors. So let us now see how to draw the ray diagrams showing image formation by convex mirror by using the rules that we have learnt just now. Now see, in case of convex mirror, we see here on this is the surface which is this side is reflecting. So we can place an object on this side. It is not like concave mirror where focus and center of curvature were lying in front of it. So it means in this case we have only two cases. We can have only two cases to place the object. Case 1, when the object is at infinity, means object is in front of it but it is far away from it. And case 2, that object is in front of it but at finite distance, close to it, not far away at infinity. Here we don't have 6 cases like that we have in concave mirror at C, at F, between C and F, because if we place the object at C, between C and F or between F and P, it means we are placing the object behind the mirror. In that case, no image will be formed. Now many times I have seen students when I give the question, draw the ray diagram showing the image formation by convex mirror when the object is placed between C and F. Students draw the wrong diagrams. You should know that in that case you should be smart enough to draw this figure, place the object here, anywhere wherever it is asked. You can place the object here and just mention that even if the two rays, you show the two incident rays, but you can show that, you can easily mention that this side is non-reflecting, so no image will be formed. It was as simple as like this. Now let us consider this case. So here we have only two cases. Let us consider the case 1, when the object is at infinity. And if you remember, when the object is at infinity, the rays striking the mirror will be parallel to the principal axis. So in this case, if the object is at infinity, rays are coming. In the case of infinity, we can draw 3 rays. One this one incident normally, one is this, and we can draw this. Okay, so I have taken 3 rays. In case of infinity, we can draw 3 rays, no problem. So 3 rays which are parallel to the principal axis, which are parallel because they are coming from object at infinity. We know that they appear to be, whenever the rays are parallel, they appear to be coming from focus. So this is dotted and this is solid. This is our reflected ray. When this ray, which is incident normally, in this case of normal incidence, my reflected ray will be this. I is equal to R is equal to 0 degree. In this case, if you want, you can also draw the normal. If you feel like you can draw this normal, it's not very difficult in this case, and you can show this is I, this is R. For this case, again, if you want, you can draw the normal, but it's not required as we have already formed the rules now. Okay, and the reflected ray, we know it is going to appear, it will appear to be coming from focus. So here I have rays which are parallel to principal axis coming from the object at infinity. After reflection, these 2 rays we have got, following the laws of reflection, we know parallel rays appears to be coming from focus. So this is erased. This. So these 2 parallel rays, after striking the surface of the mirror, appears to be coming from focus, as shown here. But remember, the lines which you have produced behind the mirror should be dotted. These normals are also represented by dotted lines. Now, where is the point where the rays meet or appear to meet after reflection? We know that here this is first reflected ray, second reflected ray, third reflected ray. It means they are diverging this side. They will not meet. So where are they meeting? We can easily see that the reflected rays meet at focus. Otherwise also we have seen this figure before while I defined principal focus of a convex mirror. So in this case, when the object is at infinity, where is image's position? Here. It means at focus. What is the nature? Students, I hope by now you should be able to, answer actually when I ask you this question. But think over it. Tell me. The rays appear to meet. Oh, sorry, you can't tell because you can just listen to me. The rays which are parallel to principal axis appear to meet at focus. So here, appear to meet at focus. So nature will be real or virtual? Yes, it will be virtual and erect. Because when the rays actually meet, then it is real and inverted. Here the rays appear to meet after reflection which are coming from an object. So the image is virtual and erect. Since they are meeting at small point, 1 point focus, so size will be highly diminished or very small. Point size, we can also say point size image. Now let us consider the second case where, so I hope this diagram is clear to you. Okay, you should not have any difficulty in drawing this diagram as we have already learned the rules before also. Now let us consider the next case. Here we can show the object. Try to take a small object only, it is always better. AB. As we have learned before, from tip A we have to choose any two rays. Let me take one ray which is always preferred parallel to the principal axis. If you want, you can draw normal here, but otherwise you can draw the normal. But even if I will draw the normal, there is no need to take tension that which will be my reflected ray, because I know that a ray parallel to the principal axis appears to be coming from focus after reflecting from convex mirror. So I will join focus and this point of incidence, and I'll produce it backwards by using dotted line. This is my reflected ray. So I have considered this one ray which is coming from A parallel to the principal axis appears to be coming from focus. Now next ray, I can choose the oblique ray, okay. I can choose the other ray which is directed towards focus and becomes parallel, but I prefer to choose the other ray which is directed towards C. So you have to join C and this point. Join C and this point, but here it should be solid. Here it was dotted because behind the mirror we have to show dotted line only. So which is this incident ray? This is that incident ray coming from A, which is directed towards center of curvature. If you remember, the ray which is directed towards center of curvature, it means this dotted line C and this point of incidence, this is nothing but normal. So this is a case of normal incidence. So in this case, my reflected ray will reflect back like this. Okay, this is a case when I is 0 and R is also 0 degrees. Okay, now, so I have chosen two rays, one ray parallel. This is the corresponding reflected ray. The other ray which I have chosen is directed towards center of curvature. So it is incident normally. In that case, it reflects back along the same path. Okay, and where they meet, reflected rays, where do they meet? Now this is my one reflected ray and this is my another reflected ray. You can easily see that they are diverging. So they are not going to meet this side. Where do they meet now? Here. This is one and this is the other reflected ray produced backwards. So this is the point of intersection. Image of A dash, and I'll draw the image preferably dotted arrow B dash. Okay, so this A dash B dash is image of AP. Now you must have understood, I think so you must have understood why I have chosen this ray, because this is a very convenient, easy ray. When we draw this incident ray, there is no need to draw other reflected ray. You can just reverse the arrow and you can get the reflected ray. So this is a very good ray which should be chosen. Okay, so in this case, now image position. Why I have drawn this dotted image? Because the rays appear to meet here. So image form is dotted. It means nature is virtual and erect. What about its position? Between P and F, behind the mirror. Between P and F, and you can write behind the mirror. Size, we can easily see, compare the size. This is the size of object, this is the size of image. So it is diminished, smaller than the size of object. Okay, so we have only two ray diagrams showing the image formation by convex mirrors. You can try here, you can place the object little bit far away or closer to it. Every time when you draw the ray diagram, you will see that image is formed between P and F somewhere. Okay, so the image is always formed between P and let me write it like this, between P and F. Okay, so in case of convex mirror, what is a convex mirror? A spherical mirror whose reflecting surface is curved outwards. In case of convex mirror, we see that only virtual image is formed. In both the cases, virtual image is there. And either it will be highly diminished when the object is at infinity, very far away from it, or it will be diminished. So we always see small sized image or highly diminished image when we place object in front of convex mirror. Hope you have understood these ray diagrams very well and you can practice it, you can draw on your own without doing any mistake. Just remember, polishing is must first of all. Don't forget this polishing, otherwise you will not get marks. Secondly, don't forget to put these arrows in the proper direction. Okay, one arrow is required for each ray. Like this incident ray, one arrow. For this reflected ray, one arrow. Okay, so for every ray, whether it is incident or reflected, you have to put arrows. MM dash is aperture, P is a pole, F is a focus, C is a center of curvature. If you miss anything, you can lose marks. Prefer to write this image properties close to the ray diagram whenever you are asked to draw the ray diagram. Now let us see the comparison between images formed by concave mirrors and convex mirrors. In concave mirrors are spherical mirrors whose reflecting surfaces are curved inwards. In concave mirror, as C and F lies in front of mirror, we can have 1, 2, 3, 4, 5, 6 different cases to place the object. And in case of convex mirror, we have only two positions for object. Two positions means two cases. One, the object is at infinity, and the other, it is placed close to it. Now just try to recall and look at the diagrams that here the image, when the object is at infinity, we can show here dotted lines. Then the image formed is real and inverted, highly diminished. In this case, when the object is beyond C, image form is, again, rays are actually meeting, so it is real and inverted but diminished. Here object is at infinity, image is formed at focus. When the object is beyond C, image is formed between C and F. Now third diagram I have not intentionally completed because I know that even if there is slight error and your ray diagram can go wrong. So here you can do little manipulation. What kind of manipulation? Just see here. I have taken this F, I'll write F afterwards, sorry. I have taken this point is now C. This is a case when the object is at C. So this is a C point, this point. I have placed the object here first. A, B is the object. From A, I have to choose two rays. If I take two rays, one parallel to the principal axis that I can draw, the other passing through focus. Okay, I have not intentionally drawn this ray first. I have just drawn the incident ray. Second ray, I have to choose here. I can choose passing through the focus, which becomes parallel to the principal axis. Why I have not drawn that? Because if I draw the reflected ray here, and if I draw incident ray and then reflected ray, with slight error, the rays may meet here or here, either towards the left or towards the right. If you do that, even if you have worked hard, your ray diagram will be wrong. You cannot be given marks for it. Because in this case, when the object is at C, image should be formed at C only. So in this case, what you can do is place the object AB. First draw the image just below AB of the same size and name it A dash B dash. Draw this incident ray. Draw this one ray parallel to the principal axis from A dash. Now join this. Join these 2 points and then join these 2 points. This and this. Join these 2 points. This point and this point. Okay. Now, just write it F. This is now incident ray. This is reflected ray. This is incident ray. This is reflected ray. And you can just produce this ahead. You can just produce it a bit more. Because you should always, whenever you form the image, your rays should go beyond that point of intersection. So in this case, there is no chance of error at all. You have already drawn the image first. Okay. So the object is at C, image is formed at C only. Okay. So this is a better way, because slight mistake can give you wrong position and it will be either your wastage of time or your loss of marks. In this case, we see that what kind of image is formed? Real, inverted and same size. In the next case, when the object is between C and F, see, object is here. We can see image is formed beyond C and it is enlarged and real and inverted. In this case, when the object is at focus, then we have seen that the rays become parallel after reflection and we write they meet at infinity. So image is formed at infinity and it is highly enlarged, real and inverted. In the last case, when the object is placed between F and P, after drawing the ray diagram, we have already drawn it before, we see that the image is formed behind the mirror. So in this case, the rays appear to meet and the image is formed. So obviously the image is virtual and erect and lies behind the mirror. So when we look at all these 6 ray diagrams, we can say using concave mirrors, we can get real and inverted images also, as in the first 5 cases, and virtual and erect also. But virtual and erect is always magnified when we get the image from concave mirror, and real and inverted images can be point size, diminished, same size, enlarged, highly enlarged, depending upon the position of the object. So it means using concave mirror we can get real as well as virtual images. Real images of different size, virtual always enlarged, magnified only by concave mirror. And let us just now, only we have learned convex mirrors ray diagram. In this case we have only 2 cases. So in these 2 cases we have seen that either when the object is at infinity or at finite distance in front of the mirror, image formed is either highly diminished as in this case or smaller than the size of object as in this case. So we are going to get only virtual and erect image when we look the object, keep the object in front of convex mirror. Okay, and it is unlike concave mirror where the virtual image is magnified. In convex mirror, it is highly diminished or diminished only. Okay, so you should try to remember the properties of image formed for the different cases in each of these 2 types of mirrors. I hope the topic is clear to you. If these topics are clear to you, then you have done a great job, and hope you will continue watching video. If you have understood this, hope you will give very good comments. Thank you. See you in the next video.